Day 61, illustration number 4. This will be the last one. Okay, in the first picture here, we can see a dime being laid on top of a piece of granite. And in this granite, you can see these very large areas of different colors. These are the different crystals that were formed when the magma cooled very, very slowly under the ground. So off to the side here on the left, I'm going to turn the paper here sideways. Let's write the word liquid, cools, and solid. Liquid, and then an arrow with the word cools next to the arrow, and then solid. That's to remind us that igneous rocks are formed when a liquid rock, whether it be magma or lava, cools into solid rock. And this forms igneous. Igneous rock. Okay, above the picture, I want you to write down slow cooling equals large crystals. Slow cooling equals large crystals. And you can see that some of them are almost as big as a dime. Now off to the right-hand side, we have the same kind of rock, only after it has experienced a lot of heat and pressure. We can turn this granite in the first picture into this kind of a rock, which is called gneiss. And that is because of heat and pressure. So we're going to write that up here. Heat and pressure. And draw some arrows from the granite sample on the left to the gneiss sample on the right. That heat and pressure turns the granite into this. And notice that the crystals are no longer so visible, and things are in stripes of sorts. Things are more blended together. So underneath the rock here, I want you to put more blended. And all of that results in a metamorphic rock. So up here in the upper corner, write metamorphic. Metamorphic rock. Now the metamorphic rock, remember, can happen because of heat and pressure. We've talked about magma changing surrounding rock into metamorphic, but there's another way of it happening, and that's going to be illustrated here in the next row down. We have a picture of, this is the ocean, then we have mountain ranges here, and it shows here, it might be hard for you to see, but it shows these huge, huge layers of rock. They could be the size of an entire continent, and little arrows moving down. So this giant section of rock is being pushed down into the earth. And over here, underneath the mountains, we have another layer, and there's again an arrow pointing to the left in this case, showing that this giant section of rock, again, perhaps the size of a continent, is being pushed to the left. And in this area here, then, we have lots and lots of extra pressure. And in this pressurized zone, we can have whole regions where rocks are being turned into metamorphic rock. So let's write this underneath this picture here. Pressure of moving rock changes into metamorphic rock. Okay, so the pressure of the moving causes rock to change into other metamorphic rock. So either heat or pressure causes things to change into metamorphic rock. So the next picture here, I just want to illustrate that we have a fossil of some sort. This bug died and was quickly buried by different kinds of sediments. Sediments can be dirt, sand, small pebbles, all sorts of stuff. And it has to be buried quickly. Buried quickly by sediments. If it wasn't buried quickly, then the little body would rot and decompose and would not be discernible by us. But since it is buried by sediments, it then has to be compacted, which means squeezed together, and cemented, glued together in some way. The process is called cementation, and the act of compacting it is compaction. Anyway, you have to have the right conditions for compaction and cementation, the right kind of pressures, the right kind of temperatures, the right kind of chemicals around, and if all that happens, then we get sedimentary rock. We only find fossils in sedimentary rock. The heat of lava and the pressures of other things cause the remains to become indiscernible and we can't see them anymore. The last two pictures, I just want you to see that here we have cementation of pebbles. All of this is glued together. So this type of sedimentary rock is called a conglomerate. It's when you have large pebbles that have undergone cementation or gluing. And in the last picture, we have all sorts of fossil shells that are put together. And again, these are all cemented together, so it's more fossil than it is rock. The cementation of shells. That's another kind of sedimentary rock. Oops. So that is the end of illustration 4.